Hello everyone and welcome to this comprehensive demonstration of my Geosteering Trainer application, a tool designed specifically for geological analysis and reservoir boundary interpretation. Today, I'll walk you through this application that focuses on the critical correlation between typewell vertical gamma ray recordings and horizontal gamma ray data from deviated wells. This application serves a purpose in the oil and gas industry. It allows geologists and drilling engineers to accurately draw and interpret reservoir boundaries by correlating gamma-ray signatures between reference wells and horizontal drilling trajectories. The correlation process is essential for optimizing drilling paths and maximizing reservoir contact. Let me introduce you to the main interface, which features three primary visualization panels that work together seamlessly. On the left, we have the reference vertical GR well plot. This displays the gamma-ray log from our typewell, which serves as our geological reference. In the top, you'll see the gamma-ray correlation plot, which shows both the deviated well's gamma-ray readings and the mapped reference data. Finally, we have the trajectory and structure plot, where we visualize the wellbore path and define our reservoir boundaries. The interface is designed with a dark theme that's easy on the eyes during long analysis sessions. Notice how each plot is clearly labeled and uses distinct color coding: purple for trajectory paths, green for deviated gamma-ray curves, and blue for reference data. One of the powerful features of this application is its fully resizable plot dimensions. You can adjust the relative sizes of each panel by dragging the splitter bars, allowing you to focus on the most relevant data for your current analysis. The status bar at the bottom provides real-time information about cursor position and curve values as you move your mouse across the plots. This dynamic feedback system displays precise coordinates, gamma-ray values, measured depth, true vertical depth, and even calculates dogleg severity and other trajectory parameters in real time. This immediate feedback is invaluable when making precise geological interpretations. The application includes a comprehensive project management system accessible through the menu bar. You can start a new project, save your current work, and load previously saved projects. This functionality is essential for collaborative work environments where multiple geologists might work on the same dataset or when you need to revisit previous interpretations. Let me show you the menu structure. We have file operations for project management, data menu for loading various input files, analysis tools for calculating results, and view options for customizing the display. Each menu item has keyboard shortcuts for efficient workflow. Now let's begin with the data loading process. First, we'll load the typewell gamma-ray data. The application supports multiple file formats including CSV, Excel files both, and XLSX and text files. This flexibility ensures compatibility with various data acquisition systems and logging software commonly used in the industry. For the typewell gamma-ray data, the file structure should contain two essential columns. The first column represents depth values, typically TVD true vertical depth, and the second column contains the corresponding gamma-ray readings in API units. The application automatically detects the file format and decimal separators, making it compatible with international data standards. Once the reference data is loaded, you can see it plotted in the left panel. The application provides sophisticated zoom and pan controls. You can use the mouse wheel to zoom in and out, drag to pan across the data, and right-click for additional zoom options. The auto-ranging feature ensures that your data is always optimally displayed. Notice how the gamma-ray curve is displayed with professional styling and grid lines for easy reading. The inverted y-axis follows industry standards where increasing depth is displayed downward. Next, we'll import the trajectory survey data. This file typically contains three columns: measured depth, MD, inclination angle, and azimuth angle. The application uses advanced mathematical algorithms to compute the complete 3D trajectory from this survey data. The trajectory calculation engine uses the minimum curvature method with number acceleration for fast processing of large datasets. It automatically computes true vertical depth, vertical section, northing, and easting coordinates for each survey point. This comprehensive trajectory model is essential for accurate geological correlation. Now comes the most critical part of the workflow: defining reservoir boundaries. The application uses an intuitive double-click interface to add boundary points directly on the trajectory plot. Each double-click adds a new boundary point that represents where the wellbore intersects the reservoir top. As you add points, the application automatically numbers them from left to right based on measured depth, making it easy to track your interpretation progress. The points are color-coded with distinct colors for easy identification, and they can be moved dynamically to refine your interpretation. For precise geological interpretation, you can zoom in to specific sections of the trajectory and add additional boundary points. The application includes sophisticated collision detection points cannot cross each other, maintaining the logical sequence of your geological interpretation. You can drag points to new positions, and the application will automatically update all correlations in real time. This immediate feedback allows you to see how small changes in boundary interpretation affect the overall correlation quality. The application includes advanced point editing capabilities. To remove a point, simply middle-click on it or use the context menu. The point numbering system automatically updates when points are added or removed, maintaining consistency in your interpretation. Each boundary point displays detailed information including its number, measured depth, and true vertical depth coordinates. This information appears in the status bar when you hover over points, providing precise positioning data for documentation purposes. One of the most innovative features is the constrained movement system. By holding the V key while dragging a point, you can restrict movement to vertical direction only, maintaining the measured depth while adjusting the vertical position. Similarly, holding H allows horizontal-only movement. This constrained movement is particularly useful when you want to maintain structural consistency while fine-tuning your interpretation. The cursor changes to indicate the active constraint mode, providing clear visual feedback. As you define boundary points, the application continuously updates the gamma-ray correlation in real time. The reference gamma-ray curve is mapped from the typewell coordinate system to the deviated well coordinate system using your boundary interpretation. This mapping process involves complex coordinate transformations and interpolation algorithms. The correlation quality is immediately visible in the gamma-ray correlation plot, where you can see how well the mapped reference curve aligns with the actual deviated well gamma-ray readings. Green curves represent deviated well data, while blue curves show the mapped reference data. The application includes comprehensive export capabilities. You can export individual plots as high-resolution images for reports and presentations. The plots maintain their professional styling and color schemes when exported, ensuring consistency with industry standards. Additionally, you can export the process data including trajectory calculations, boundary point coordinates, and correlation results to standard formats for use in other geological software packages or for regulatory reporting requirements. After completing your geological interpretation, the application provides powerful analysis tools. The in-zone analysis calculates the percentage of the wellbore that remains within the defined reservoir boundaries. In this example, we can see the result indicates room for improvement in the drilling performance. The analysis report includes detailed statistics such as total drilled distance, in-zone distance, and performance percentages. This quantitative assessment is crucial for evaluating drilling efficiency and optimizing future well plans. The application also provides correlation analysis tools. The gamma-ray correlation analysis computes statistical measures including correlation coefficients, mean differences, and maximum deviations between the reference and deviated well gamma-ray curves.